Welcome, and we're working on the segment addition postulate. As it states in the definition, in geometry, the segment addition postulate states that given 2 points, A and C, and a third point, B, lies in segment AC, if and only if the distance between the points satisfies this equation. Now, basically what the equation is trying to tell you is that if you have this segment, which is 4 centimeters, this segment, which is 10 centimeters, and if you add those together, does it give you the overwhelming length of it? And yes, it does. Then the segment addition postulate does work. Let's take a look at some examples here, and we'll start simple and we'll get to some more difficult ones. On the first example here, it's basically stating that if I take 14 plus the question mark, I will end up with the grand total of 30. And solving this just as an algebra problem, if I subtract 14 over, I will get the answer of 16, just to kind of make sure I had the right answer there. All right, now look at the next one. Now, what's kind of tricky about the next problem is that it wants the full length from E to C. It wants that whole length. It's almost wise to kind of go through and find all the other missing parts. Find E to D, C to B, find all the parts, and then just go ahead. Last step is find EC, find your solution. So the best option here is that if I actually subtract 49 from 30 here, this whole length here is 30, I can actually take, to get this little segment here, 30 minus 16, 30 minus 16 is going to be 14. That's this small segment. Now, if I go over to the other end here, it shows me that this whole side, this whole length of this is going to be 49. If I take 49 and subtract it from the addition of 16 plus 40, it will give me the result of EC. So if I take 49 minus 30, which is 19, that is going to be the length of EC, my final length there. If you go through and add up all three of these will give me the total length of that whole segment, which is 49. Looking at example 3, what we're looking for is solve for x. Notice we're just looking for x, so we don't have to solve for any values. The full length is 23. If I add each one together, I get x minus 6, 9, 2x minus 19. So this combines as x minus 6 plus 9 plus 2x minus 19 equals 23. Combine this together, combine my like terms. I get 3x. I get negative 16 with the other values equals 23. That's my full length. Solve this like an algebra problem. So first add 16 over, add 16 over. You get 3x equals 39. And then when you divide by 3, x equals 13. You could go into each one of these and actually plug 13 into each one, and it should give you a grand total of 23 by the time you add this all together. And again, it's just a nice little guess and check, just checking method. The last one's a little bit confused because there's segments that are overlapping that gives me the 14 plus x. So that's going to be critical as I solve this problem. So first of all, what I want to do here, I want to try to figure out what adds up and what gives me like the total solution. Now, if you notice, the 26 plus x gives me the full length. That's the full length of the whole segment. If I take x plus 23 plus 12, well, that's given me this extra piece a little bit extra. It's counting it twice because it's counting it on this segment and it's counting it on this segment, counting it 2 times there. So what I have to do is remove the 14 plus x, and which will give me the grand total of that whole segment. Now, if I go ahead and do my algebra work here, I get x plus 35 minus 14 minus x. I'll work on the other side in a sec here. Cancel the x's. 35 minus 14 will give me 21. The other side is 26 plus x. Subtract 26 over, and I get negative 5. Now in this problem, it does not say solve for x. It says solve for EG, which is this whole segment, which was technically this segment that I have right here. So if I basically take the -5 plus 23, combine that together, that will give me the full segment of EG, which is 18. Thank you, and I hope you enjoyed this.